Let's start with 12.6 today, and this is my favorite in this chapter. This is like the big deal in this chapter, and it's my absolute favorite. So we're going to start talking about the unit circle, and then we're going to come back to this stuff up here, okay? All right, so let's talk about what that term unit circle means. Basically, the unit circle is a circle whose center is at the origin, and it has a radius of 1 unit. Okay, that's what a unit circle is. So if I were to draw a unit circle, it's 1, 1, 1, 1. That's how I draw a unit circle. All right, just 1 and all. That's it. The radius is 1. So now, if this radius, if that's a radius and that's 1, that's also a radius. And how big is that line? Also 1. And that's also a radius, and that's also 1. Okay? Now, so when we, in this triangle, in this circle now, what I'm going to do is I'm going to draw a triangle, a right triangle. I'm going to inscribe a right triangle. Do you know what inscribe means? That means like one of the vertex, like I'm going to draw a right triangle so that one of the vertices touches that. So here's my triangle in the green. The slanted line is the hypotenuse, right? And do you see how that hypotenuse here is also the radius of the circle, right? So that's a 1, correct? Now, if I draw another random triangle here, suppose I drew another random triangle there, a right triangle. Okay, another right triangle. So that one vertex of the triangle, one angle of the triangle touches the circle. Okay, here's my radius. I'm sorry, here's my hypotenuse, right? How big is that hypotenuse? 1, because it's also a radius of the circle, correct? So you're probably seeing that pattern. If I were to draw another right triangle here, okay, here's the hypotenuse. How big is the hypotenuse? How much? 1, because it's a radius of the circle, right? So now let's take a look at our special angles. Remember our special angles, our special triangles? This is a special triangle. I'm going to draw a 30, 60, 90. Whoops. Okay, now, suppose this has a side of 1. How big is the horizontal side? √3. And how much is the hypotenuse? 2. Okay, now, if this circle has a radius of 1, can I take this triangle and fit it in there as it is? No, it won't fit in there, right? It's too big to fit in there. Is that right? So you know what I have to do is I have to go like Photoshop, okay? And I have to like Photoshop style scale it down so that it does fit. I want to scale down that triangle so that the hypotenuse is half the size. So it's a 1. All right? So now what I want to do, right, I just want to like cut it down to size. So now if the hypotenuse was a 2, if I do it in Photoshop, it's by ratios, right? What do I have to do to the 2 to get it to be a 1? Divide by 2, so this will become a 1, right? But now, if you do this in Photoshop, everything will be scaled down proportionally. So if I divided this by 2, how much am I going to divide this by? 2. So what'll it be? 1/2. And what about this one on the bottom? √3/2. Have you seen those numbers before? 1/2 and √3/2. Where?
With the circle. I can't remember the name, but
Yeah. right? Where did we see them before? Right? Okay, so, well, you'll see where we've seen them before. All right, so let's do it here. So we need to rescale our special triangles. So now that I've scaled this down, I can take this and I can fit it in that circle. Is that right? Yeah. Okay, so take a look here now. Okay, can you sit properly? Thank you. Okay. That's the one. That's the one. Okay, so now these are supposed to be right triangles, so let's make them right triangles. So when I scale them down into a hypotenuse of 1, then this side will be 1/2, and this side will be √3/2. Okay? Look back here in chapter 1, in lesson 1, right? Did we do those in lesson 1? And what did we get? Look, it was the same players, √3/2 and 1/2, √3/2 and 1/2, right? Because no matter what, you know, when we did opposite over hypotenuse, we got √3/2 and 1/2. So now, what about this one? Originally, this was 1, 1, and √2. But now what am I going to divide by? No, this one. It's √2. But for the 45, 45, 90, I'm going to divide by √2. So this is a 1. So I divide this by √2. And I divide this by √2. So how much will they be? √2/2, √2/2. So now, let me ask you this. Look at this 30-degree angle. Okay? Now I want to find the sine of 30 degrees, right? Sine of 30 degrees. Remember how we said it was opposite over hypotenuse, right? Well, if I do opposite side, it's 1/2. Over hypotenuse, it's 1. 1/2 over 1. How much does that give me? What's anything over 1? The same. So it's 1/2. So now, what's cosine of 30? It's adjacent over hypotenuse. It's √3/2 divided by 1. So how much is it? √3/2. Right? So what do you notice? Sine of 30 is 1/2. Once we rescaled it, sine of 30 is the same as that opposite side. Do I even have to do that divided by the hypotenuse? No. Do I have to do cosine equals that over the hypotenuse? No. The purpose of rescaling is when I want to do sine, cosine, tangent now, I don't have to mess with hypotenuse anymore. So remember how we used to say SOHCAHTOA like this? Guess what I'm going to do? With this, when we scale it down, we can get rid of the hypotenuse. So, what's the sine just equal to? Just opposite. What's cosine just equal to? Just adjacent. All right? So you can get rid of the hypotenuse. Isn't that cool? That's what we're going to do from now on. So from now on, that other triangle here with the 2 as like this triangle, from now on, that triangle is dead to us. We never use that ever again. Never again do we use it. We now just have these 2 triangles. I have a 30, 60, 90 with just 2 different sizes. 1/2 √3/2. And then the 45, 45, 90 with a side of √2/2. Okay? Okay. So, here we go. Now, we're going to place a rescaled triangle inside the unit circle. Here, a 30, 60, 90. So, this is 90 here, right? Now, look at this triangle. I have 2 sizes for the legs. One is 1/2. One is a √3/2. Of those 2, which one is the bigger number? 1/2 or √3/2? Root 3 over 2 is bigger. How do I know that? 1 divided by 2 and then root 3 divided by 2. Root 3 is bigger, so that's the bigger number. Okay? So this is bigger. So now I come here. This is my 30-degree angle. Is the opposite side the small side or the big side? The small, right? So that takes the small value of the 1/2, and then the bigger side takes the large value of the root 3 over 2. Do you guys see how I did that? Okay. Now, so that's what we did here. We labeled the sides of the triangle. And how much is the hypotenuse? 1. You know what? I'm not even going to label it because we don't even care about the hypotenuse anymore. Okay? Now, fill in the coordinate of point P. Okay. So now, I want to go from the origin to point P. How do I get there? I have to go horizontally a little bit, and I have to go vertically a little bit. How much do I go horizontally? Root 3 over 2. So this coordinate is root 3 over 2. Yeah. How much do I go up? 1/2. So that coordinate is a 1/2. Okay? Now, no, the hypotenuse is 1. It's a unit circle. The hypotenuse is always 1. Yes.
So this is a very stupid question. I'm probably missing something. But if, let's say you were doing this for architecture and you were drawing that, what if it was what if the hypotenuse measured out should be 2 inches?
Well, then you have to scale back. Okay, but that will never happen then you're not dealing with a unit circle. Okay, you're just dealing with a random circle with a radius of 2. Okay, yeah. 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 That's exactly it. So now let's find cosine of 30. How did we do cosine of 30 initially? It used to be adjacent over hypotenuse, so how much would it be? Root 3 over 2 divided by 1, how much is that? Root 3 over 2. And sine of 30, it's opposite over hypotenuse, 1/2 divided by 1, how much is that? 1/2. Okay. Can you come up with any conjectures? So now it's your turn. Can you come up with any conjectures here? Based on what we've done, can you come up with any conjectures? So we just between B, C, and D. Can you come up with any conjectures here? What's a conjecture? With any theories, with any patterns? What do you think? Huh?
It's always root 3 over 2 for the longer leg and 1/2 over 2.
Okay, so that's number 1. It's always root 3 over 2 for long leg and 1/2 for short leg. Good. Any other ones? Any other patterns? How about in terms of these values and that coordinate point? What do you see? How? What is equal to what? X is, and that's the value of the what? The sine or the cosine? The cosine. So look at this. Cosine of 30 is root 3 over 2. It's this one. Right? And that's the x value. And then this value is the what? Which is, it's the same as the sine. Okay, there is no cotangent. So when I find the coordinate point of this point, so how did I get this point? How much did I go across? How much did I go up? That gives me the coordinate point. Once I get the coordinate point, the x value is always the cosine. The y value is always the sine. Okay? So in the coordinate point, x is always sine of theta, cosine of theta. Y is always sine of theta. There is no cotangent though. Okay, I'm not dividing x by y. I'm just saying the x as it is the cosine, and the y as it is the sine. Yeah. The third pattern I want to come up with is, how did we get that y value anyway? It's the what? It's which side? It's the vertical leg. And the cosine is the horizontal leg. Okay? So, horizontal leg is the cosine, and the vertical leg is the sine of theta. Okay? All right, let's fill in some of these now. Okay, let's do this. Take a look at this. How many degrees is that here? Huh? 30. Okay? So now look at this. I have a 30-degree angle on my unit circle. Do you see the 30-degree angle? It forms a right triangle. Now, I have 30 and 60. Is 30 the bigger angle or the smaller angle? Smaller. Does it face the bigger side or the smaller side? Smaller. In a 30, 60, 90, my possibilities are always 1/2 or √3/2. So is this vertical side going to be 1/2 or √3/2? 1/2. And how much is the horizontal going to be? √3/2. So now I think to myself, okay, to get from here to that point, how much do I go? The horizontal is √3/2 and the vertical is 1/2. Horizontal is x √3/2 and the vertical is 1/2. Okay? Now, look at this angle here. This is 150 degrees, right? But if I draw a triangle here, okay, how much is this angle here? 30 degrees. So now, how big is this vertical side? Vertical side, how much? 1/2, that's the smaller one. How much is this horizontal side? √3/2. So now, to get to this point here, how much do I go horizontally? √3/2, and how much do I go up? 1/2. But, no. But I go √3/2 in the negative direction, right? So this is negative √3/2 and 1/2. Does that make sense? Negative √3/2 and 1/2. Now, okay, what about this one? Okay, so this is 210 degrees. So if I were to draw a right triangle here, right? How much is this angle right here? 30 degrees. Okay, so how much is this vertical side? 1/2, right? How much is the horizontal side? √3/2. Okay, so come up with these coordinates now. How do I go from here to here? How much do I go horizontally? How much do I go vertically? And are they in the positive or the negative direction? So come up with those. Then what I want you to do is do the same thing for the 330 degrees. Okay, what do we have for the 210? Ethan Stubbington, what do you have for the 210? What are your values? I don't know, you tell me. Which one would be negative? 1/2 would be negative. Okay, is that right? Both are negative. Good. That's what he said. That's what we just misheard. Okay, Andrew Gussman, how about the 330? negative 1/2, and positive root 3 over 2, like that? You're shaking your head. Why? Radical root 3 over 2 goes first, and 1/2, negative 1/2 goes second. Okay? So when I'm doing this, right, for myself, this is how I reason through them. Okay? So now, you know what? Let's do this one. I'm going to erase some of this clutter. Just this one. Because you go root 3 over 2 and then down 1/2. Okay, now you know what? Let's go to 60 degrees. I'm going to draw an angle here. Okay, now look at this. Now look at this. What's the angle here? What's that angle? How much is this angle here? How much? 60. This one here is 60, right? Because I went up to 60. So, is the vertical the long side or the short side? Long side. How much is it? Root 3 over 2. And how much is the horizontal? 1/2. So, tell me the coordinates here. 1/2 and root 3 over 2. Are you seeing the pattern? Okay. I'm not going to do every single 60 because I think we're good. But I'm going to do a 45 degree. But you know what? I'm going to spice things up a bit. I'm going to do 135 degrees here. All right, so let's draw that. Here. Okay, this is 45 degrees here, right? Because it's 135, so that's 45 degrees. What do I know about the length of the vertical and the horizontal? They're the same. And how much is it? Root 2 over 2, root 2 over 2. So now, oh my God, I did something that I hate. You know what it is? The slanted fraction bar. I hate it. And I did it. I'm sorry. I hope you'll forgive me. So what are the coordinates there? Negative root 2 over 2 and positive root 2 over 2. Okay? We're good? Now, take a look at this. There's this mystery angle. It's one of these. Okay? You see how these, like we had these like coordinate points here? Okay, so now I have a random coordinate point. Okay? And the question asks you, what is the cosine and what is the sine? So just looking at the, I'm not going to look at the circle, just looking at that coordinate point. What is the cosine and what is the sine? So what did we say before? Between the x and the y, one of them is the cosine, one of them is the sine. Which one is which? X is cosine, so it's root 3 over 2, and sine is 1/2. Have I done any math? No. All right, I just recognize that that's what the coordinate looks like. Now, I'm going to add to this and find the angle. All right, this is going to be on your handout today, so let's do it. So find the angle. For which angle is it root 3 over 2 and 1/2? So for which one do you go root 3 over 2 and 1/2? 30. Okay, so you go longer and shorter. And now, how do I know? 1/2, that's the vertical. That's the smaller in the vertical, so I must face the smaller side. So it's 30 degrees or pi over 6. Okay? Okay, this one. What's the cosine here? Root 7 over 4. And what's the sine? 3 over 4. Okay, for this one, you can't find the angle because it's not a special angle. It's not on the unit, like it's not one of the special angles. But on the one on the homework, they'll all be that. Okay, now, what did you notice here? what did you notice here? About the sign, like SIGN, the positive, negative. Here, look at the X values. Are they positive or negative? Positive. Look at the Y values. Are they positive or negative? Positive. So here, it's positive, positive. What about in this quadrant? What is it? Negative, positive. What about here? Negative, negative. And what about here?
Positive, negative.
Okay. Okay. Now, guys, look. Huh? Yeah. It's just like on the grid, right? Because this is the positive x-axis and the positive y-axis. Positive x-axis, negative y-axis. Now, this coordinate, the x-coordinate, is that sine or cosine? Cosine. And this one is sine. So look, here, this one is cosine, this one is sine. Cosine, sine. I know this is getting kind of crowded. Okay, can you name all of the quadrants where sine is positive? Sine of theta is positive in quadrant 1 and quadrant 4, right? How about cosine?
No, it's not positive. It's 1 and 2.
Ah, I'm so sorry. 1 and 2. Oh my God, I'm so sorry. What about cosine? 1 and 4. Okay. How do you get tangent? It's what over what? Opposite over adjacent. Okay. So tangent is opposite over adjacent. But all this time, we've been saying the y value is sine of theta, and the x value is cosine of theta. So, if I do sine over cosine, opposite over adjacent, does that give me tangent? That gives me tangent. So now, here, if I do sine over cosine, that gives me tangent. If it's positive over positive, would tangent be positive or negative here? It's positive. What about here?
Negative.
What about here?
Positive.
Ah, positive. In the third, what? Because it's negative over negative, it's positive. And here it's negative. So let's write down tangent of theta is positive in what quadrants? 1 and 3. Okay. Believe it or not, you have to remember all this at a moment's notice. Now, okay, so we're in luck because there is a little mnemonic device. You know what a mnemonic device is? Something that helps you remember. Okay? Here's the little mnemonic device on the next page. This is it. So all that we did, where, sine is positive, where cosine is positive. Okay, there is this statement. All students take calculus. It doesn't have to be a true statement. It just works for us. So if I take this statement, all students take calculus. Here's how I write it. Here I go, all students take calculus. Okay? All students take calculus. Now, you know what I'm going to do, though? I'm going to erase the words and just leave the letters. All students take calculus. Okay? All students take calculus. Okay, what the heck am I doing? This tells you A for all are positive. So sine, cosine, tangent. So in that quadrant, everything's positive. S Sine is positive. What do you think T stands for? Tangent is positive. And here, cosine is positive. Okay? So, suppose I want sine of 150 degrees. What quadrant does 150 degrees lie in? 2. Is sine of that angle going to be positive or negative? Positive. Whoops. It's positive. Now, what if I want cosine of 150? Where's 150? Here. Okay, if sine is positive there, everything else is negative. So will cosine of 150 be positive or negative? Negative. Okay? Okay? Now, why are we doing all this?